to another episode of the AKS Cost Management Series. In this video, we'll explore the topic of cost governance on AKS. What does it mean, why do we need it, and how do we enforce it? When building on Kubernetes, adhering to FinOps best practices will help to drive effective cost governance. Governance involves setting standards, establishing policies, and enforcing the best practices that teams can adhere to maintain control over resource usage and spend. How a platform team approaches governance will become more sophisticated as the organization matures. They may start with guidelines and guardrails before moving on to automation. But regardless of how strictly policies are enforced, there needs to be an iterative review cadence to ensure that the policies in place are the right ones. Cost optimization is not a one-and-done process, and neither is the governance piece of cost management. So, what are some examples of standards and policies that can be set to drive your cluster cost efficiency on AKS? Let's look at the following from a platform engineering persona. Platform engineering is a central team that defines, manages, and streamlines cluster creation, upgrades, operations, and lifecycle management for developer teams. So developers can focus less on the infrastructure and more on deploying and building applications. So example number one, in a multi-tenant shared cluster environment, standardizing on a labeling, tagging, and namespace naming convention is critical. By establishing this guidance for developers, it simplifies the process for platform teams to track costs across teams. It allows them to do cost allocation and even chargebacks, as there is a clear mapping of the application costs to the owner. Example number two, developers often do not know how much CPU and memory resources their application will need. So they often set these request and limit values too high, which leads to over-provisioning, underutilization, when the actual usage is far below the requested amount. This can lead to workload instability if a workload needs more resources than is actually allocated as well. In this scenario, the platform team can provide guidance to developers on how to set proper request and limit values, or if automation is acceptable, a tool like Vertical Pod Autoscaler can be enabled to do this automatically for the developers. VPA will provide recommendations on the optimal request and limit values based on historical workload usage and automatically right-size the pod. Example number three, an important consideration for multi-tenant environments is resource exhaustion and competition between workloads running on shared infrastructure. Resource quotas are a great way to limit the amount of resources that can be consumed by different teams or applications. Enforcing guardrails or quotas at the namespace level is a great way to ensure no single team or application consumes more than its fair share of resources. Number four, for dev test clusters, if they are not needed on the weekend or during non-work hours, consider establishing policies around stopping the cluster or scaling to zero to decommission resources. Additionally, ensure workloads are running on the most cost-effective node pool. For example, dev test workloads can often run on spot instances or lower tier VMs to reduce costs, while production workloads should be placed on more reliable or reserved node pools. Mapping workloads to the appropriate node pool type can yield significant savings without impacting stability. Example number five. On a related note, think about those resources that are not in use and have been abandoned for some time. Are there orphan resources that can be cleaned up? Consider setting a standard review cadence as a part of the cluster lifecycle to delete any orphaned or unattached resources. And our final example, consider Azure discounts. If your organization has reserved instances in place, ensure that the right SKUs are aligned to your RIs. And that means those are being utilized to maximize the benefit and cost savings of the discounted compute. These are just a few examples of best practices that can be turned into policies and standards by platform teams. Governance can come in the form of simple guidelines, or they can be guardrails which are alerted on if not complied to, or in the most strict scenarios, they can even block developer deployments in CI/CD if absolutely critical. So in summary, governance is a key piece of the puzzle to drive sustainable and continuous cost management. Policies and standards are the backbone of governance, and by implementing a comprehensive set of policies, you can ensure that your Kubernetes environment remains cost efficient, scalable, and manageable.